complex data types. Other than what we had seen till now, I think already we had seen some of these complex data type. Example, pointers are an array, but we didn't see all. Right. Totally, the complex data types are 5. Pointers, array, enumeration, union, and structures. Each one of them are used in embedded domain. Right. Even in CAPL programming, they are used to some extent, but pointers are not there in CAPL. Okay, first of all, what is pointer? Like other variables that we have in C, the pointers are also a variable. But pointer variable will hold only address. It won't hold data. So if address means always unsigned number only, no. Address are, there is no negative address. Do you agree? Do we have any negative address minus 60,752, something like that? Can we
No,
have a negative address?
no, sir.
No. So if that is the case, all address are unsigned integer only. Unsigned integer or unsigned long. You are agreeing, no?
Yes, sir.
But in pointers, we have different kind. Character pointer, integer pointer, and then float pointer, double pointer. Why the difference? Why we have this difference?
Mm, yeah, from my understanding, sir. So, character pointer means it will the pointer.
All pointers should have a unsigned integer only. All pointer variables are always going to carry unsigned integer as a value. Then why we have a difference?
Uh, yeah, yes, sir. For so character pointer means it will be pointing to the data type of the character. So it will be moving eight bits. That is 1 byte. Increment of pointer will become one byte every time if you increment the pointer.
Hmm.
So similarly for int, if it is 32 bits, so means 4 bytes. It will move 4 bytes when we increment the pointer. So for the operations of the things, we define the pointers with the data types.
Very brilliant. Actually, the pointer data type that we specify, no, it is not the content of pointer, the data type of content, data type of the content that we are going to hold in that pointer variable. It is going to be always unsigned integer. How this pointer should increment when we modify the pointer variable? That is what told as pointer type. People usually say we have a pointers of different types. Character pointer will point character variables. Integer pointer will point a integer variable. So pointer means what? Pointer is an address. It is going to have address. Address of the character variable also unsigned. Address of integer also unsigned. Address of a float also unsigned. If that is the case, why we need these sort of difference? Actually, these difference gives the meaning to the pointer, how it is going to be updated if it is incremented or decremented. Clear? Because the pointer has an ability, it can update itself with one from one value to another value. If you increment it, automatically the address will change. Got it
Yeah,
now?
yes, sir. For the purpose of purely for the operation only, right, sir?
Operation of the
Operation.
pointer. How we are going when we use it in the computations and we want to increment the address value to the next one. If it is a character pointer, pointer will move 1 byte in steps. If it is an integer pointer, as per this particular compiler, it will go 4 byte in steps. If it is a long pointer, it will go 8 bytes in step. Every time when you increment, the address value will change to 8. 8 like that. Clear? Pointer
Clear, sir.
is a variable which holds the address of another variable. Pointers are declared. How to declare a pointer? Data type of the pointer. Right. And then a star. Then the variable name that you have to give. By default, when you declare a pointer, every pointer will have a null in as their content. Null as their content means they are not pointing any address. They are not holding any address in them. Got it now? Computer uses the pointer data type to determine the size of memory block that pointer points to. When it is pointing to a particular data type, a content in the memory, right? To understand the data type of that, the computer uses the pointer, right? There are two operators to manipulate pointers. There are two operators. One is an address of operator, this ampersand symbol. Another dereference operator. It can be star or star star. When to use star? If your pointer is pointing a variable, not another pointer, then you can use star. If the pointer is pointing another pointer, so an address can also point, and pointer variable can also point a address of another pointer. Right now, see, I have a pointer variable. Pointer variable also declared somewhere in the memory only, no? What I told about pointer is pointer will hold the address of another variable. That is what I told. To store this pointer variable also, we need some memory. Yes or no? Where they are reserving that memory, same stack. Depends on the place where you declare and what is the storage class that you use. They reserve the memory in that particular place. Right. So to point address of a pointer, we can use another pointer. That is also possible. In that case, you have to declare that pointer with the prefix of star star. Only up to 2 star you can go. You cannot go beyond 3 star. So to point that address, I want to use another pointer. That is not possible. Only 2 steps are possible. Clear now? So that is called as dereference operator.
Can you repeat, sir, this one, dereference one?
Actually, when you to operate the on the pointer, we can use two operators. One is an ampersand one, which
Okay.
says address of, right? And then
Yes.
star. Star and star star means if you are using it in parameter list, they mean address and address of address. Right. When you use within a body, which means value pointed by a pointer variable and value pointed by that is address pointed by another pointer variable. That is what star star means. Right. That is what here told. A pointer can point another pointer to. So let us see some example with respect to pointer so that we can understand it very thoroughly. Right. So for that, let me create a program. Probably today I will create a repository to store all these program in Git so that you will get access to it. Boy, no. So we are going to do the same analysis that we did before to understand the pointer. Right. First, what I do, int star ptr. Otherwise, you can say int pointer. Right. I declare an integer pointer and then int num1 is equivalent to 200. And then I declare a character pointer. Right. And then char right. Now in the float, float pointer. Right. Now I want to know where these variables are first of all declared. Where these variables are declared. There should be somewhere they have to be declared right now. Where they are declared. Based on the knowledge that we have, can you tell me where they are declared? All of them
In the stack
in
memory.
the stack. Brilliant. Because the stack is the by default, when we declare a variable, default storage class assumed is auto. Auto means they will reserve the memory only in stack. Stack is a reusable memory, right, in the RAM. Perfect. So let us print them now, like printf address of int pointer ux, comma, because that is also a variable only, no? Int pointer also a variable. Only thing is its content is an address, that's all. So then num1. So we get address of all these variables that we declared. Right. We also want to know the value stored in them. So for that, what we do, I just copy it and paste it. When we want to know the value of the content of a pointer, you have to use star. I already told right now. So when you want a value from that, you can do like that. So I'm using a percentage use as such, and then when it comes to num1, I have to use percentage d. You can even use percentage x, it will work, but it will be in hexa value. As we gave here decimal, I use percentage d, and then I say num, and this is value of char pointer. It is value of char pointer. Again, it is u only because it is a pointer. So I just say char pointer and address of C, actually value of C. As it is a character, I just say percentage C and then pass C. Value of float pointer. It is going to be an address only anyway. So I just say content of float pointer, whatever the content that we have. And then value of pi. As it is a float, I put percentage F. Right. The first group will print the address of those variable. The second group will print the value of those variable. Agree? Okay. Based
Yes, sir.
on the discussion that we had, can you tell me what may be the content of int pointer, char pointer, and float pointer?
Sir, all the three will be having the holding the um, address location.
Yes, address location, but which address they used to point? Because they are variable, they have to point some address right now, but we didn't point at them, we simply declared them. If that is the case,
Then it will be null, I think, sir.
brilliant. All three will have null as a default value. Let us check whether that happens. Okay, probably I can use all because this will be more confusing to us. Let me include a slash n. The address of int pointer is 6422 right? From there, 4 bytes are reserved for int pointer. So after that, we have num. Num from 96 onwards, num starts. From 96 to 92 right now. But all are having same address 622 300. From there, 222 96 296 4-bit less. From here, character of pointer is, but okay, that is also a 4 byte they have to reserve. That's why we have from 96 to 92, 4 bytes, no? So 92. Then character to store address of C, they use 91, the very next address itself. Right. From there, float, no, 8 byte. That means 8 memory location. So they got float pointer means 91, no, 84 to 91 means totally 84 is the address. 4 to 0, 90 itself 6 byte plus 6 byte plus 1 byte. So, sorry, 7 byte. 7 byte 4, 5, 6, 7, 8, 9, 0, 1. Yeah. From 84 to 91, we have 8 byte. Right. So they have a 8 byte down to store the float pointer. No. Float pointer, address of float pointer only, no. Why it is having very huge address? 6422 84. From 84 to 91, actually it should be some 91. It is not, it cannot be 84. It should be more than that.
It is taking 6 bytes, right? So
6 bytes.
for int, we are using a
But
4
actually,
bytes.
address wise, all are same address only, no? You got the point. The character integer for all of them, address wise, we have a 4 byte offset only. 396. 96 to 92. Okay, because character beginning of that one is okay. I understood. Because beginning of that float pointer is 8 byte total. 8 byte down the line they have their address. See, 84, 85, 86, 87, 88, 89, 90, 90, 91 is the next one. There they start see, no. 90, from 84 it starts. 84, 85, 86, 87, 88, 89, 90. 7 bytes are coming, right?
Yes, sir.
7 bytes. Why it is 7 bytes? It should be 8, no?
It's a little confusing here.
84, 85, 86, 87, 88, 89, 90. 7 bytes. Okay, let me investigate that. Otherwise, 32-bit floating point number. 32-bit means actually it is 8 fours are 32. Let me investigate. After
For float
time,
also, it should be 4 byte only, right, sir? 4 bytes, I think.
float of no, yeah, when the integer is 4 byte, float will be 8 byte. But here they are using 7 byte, and that is little bit. From here, pi is they are using 80. The float pointer, they have come this address. 4 byte less from 84. They are from 80 itself, they store the pi. Pi is float. Right? Pi the float, no? So if that is the case, why they are using 4 byte? It is also float. It is also float. I have to check this. See, address wise, they are little bit different. So address as well as value wise. Up to this, the flow is perfect. When it comes to float, there is a deviation. I will investigate and revert back to. Okay, now. So
One doubt I have, sir. Sir, here, so address of int pointer means that is like address location, right, sir?
address of integer pointer is also the one memory location zone.
Yes. But here, why like
Okay,
int
one
pointer
second.
we have 300 again?
I believe there is something going wrong. See here, value of int pointer is 0x, which is null, and character pointer is some junk value. These were junk values. They are
Yes,
not really a valid addresses. Value of integer pointer, character pointer, float pointer, we cannot predict them. By default, they are not pointing any address. When we try to print some number, they are printing some junk value. That is acceptable. Value wise, they are perfect. Num1 200, CA pi is 3.14 right now. So, except this float, the addresses are, the remaining allocations are perfect. Now, what I am going to do, I am going to point integer pointer with to the integer value, integer variable, and float pointer to float variable. Like that, I am going to change their where they point, right? There, for that, what we have to do means pointer name, int pointer is equivalent to address of num1. Right now, we can do like that, right? And then char pointer equivalent to address of C. Float pointer is equivalent to address of pi. Now I am going to print the same, all these things one more time. I made an assignment, no. I pointed this pointer to this particular address of num. So now let us see whether they are working as we discussed. In which line? I think it's they throw some error. Line number 28. Yes. See, these were we no need to consider from here it all start. Right. So integer pointer, address of integer pointer is the same. There is no difference. And then num is 96. Char pointer is 92. And then C is 91. And then float is 84. And then pi is 80. Perfect. But when you look at it, the integer pointer value, char pointer value, float pointer value, everything is having a junk again. So they are not reflecting exact address right now. Maybe I think UX is the, okay, sorry. Value of int pointer, I just correct only. Value of int pointer should be address of num. 64 222 96. Agree now. That should be the result, right? Because it is pointing num1. But
Yes,
why
sir.
we get 200x? 200x is the value of num. Okay. Understood. So to do that, I have to use like this. Because as I am using star, they are printing value pointed in that memory location. Correct. Now it will do fine. It will do perfect. Let me save this and run it. Right? As I pointed, see from here it starts. Right. Address of integer pointer is address allocated for that is 300. In 96, the num1 is stored. That is also variable. All are stack memory only. In 92, we have a character pointer. In 91, we have a character variable. Right. From there, float pointer is in 84. Right. From there, we have in pi at the memory address 80. Then int pointer contain the address of num. Address of num is 96, right? No, that come here. Perfect, na? Then character pointer. Character pointer is pointing C, no? So address is 91x, that is coming here. So then they are printing the value of C actually. Then float pointer. When the float pointer is pointing which one point, the pi. The pi is at the memory location where we have pi. Address of pi is 80. So that becomes the content of float pointer. Agree? Then we are also printing the value of pi. Do you understand now?
Yes, sir. Sir, I have one doubt. So this address of int pointer, character pointer, and float pointer, they will be only like 8 bytes, right, sir?
See, the size of that size that they require to store the address. Right. So that they use 4 addresses to store integer pointer value. Number. To store an integer number, they also use 4 byte. Agree? So when it is character pointer, to store a character pointer also, they use 4 byte address, because 4 bytes to store the address. Character variable, they use only one address, because within one address we can store the value of character. Then it comes to float pointer. Float pointer alone, they use 7 bytes as per this program. Actually, it should be 8 byte.
Okay.
But when it comes to float value, they use only 4 bytes. The address of float pointer is using nearly 7 bytes. The pi, the value that we have now, 3.14, to store that, they use only 4 bytes. Maybe correct only, 32-bit floating point number. So according to that, they use that 4 byte to store the value pi that require a 4 bytes memory reserved from the stack. Clear? Integer also, they are using 4 bytes in this as per this compiler, and for float also to store it they use 4 bytes. Does that make sense?